So for this section of our talk, we're going to talk about what represents visualization and how to create visualization. While visualization is the amalgamation of science and design, it's also many sciences that have been put together to create a wider result. We can talk about the visualization pipeline, and Ben Fry did a really good job of describing this, and he divided it into these different stages. It starts with data acquisition, data parsing, then filtering the data, mining the data, trying to find the special spots where your data is interesting, finding a representation for your data, refining your data, and then finally interacting with the data. Notice that each of these parts actually fall very neatly within different sciences. There's a lot of data acquisition and data parsing that falls within computer science. Filtering and mining falls within math, statistics, and data mining sciences. The representation and refining your representation falls a lot within 2D design and graphic design, while the interaction really falls heavily on human-computer interaction as well as just InfoVis. Now, while this is a straight pipeline, it is actually not a straight process. Once you actually find your representation, you might find that the data that you have is not correct, so you might reacquire it. You might also realize that your data is too broad, so you might have to refine it, so you might have to further filter it. Once you actually create a representation and you start interacting with it, you might realize that you have to refine the way your representation is, adjust the color scheme, threshold some number value. In fact, in general, as we go into data visualization, we'll realize that most of our endeavors do adjust more to the cyclical view of design. Visualization is very much an iterative process. And you can say that we start with investigation. We find out what else is out there, what other work can help us, what tools are out there. Then we go into planning stage, figure out how we're going to achieve our results, and then we create something. Once we create it, we will evaluate it, and then we will just keep on going back to investigation, planning, creation. At any point, once you start planning, you might realize that you do not have enough feedback to actually do your results, so you might have to go back to investigation. So it's very much one of these free-flowing processes that is very common in many kinds of design and engineering. Another way to look at this is different levels of involvement, how in-depth your visualization project will be. The first step is usually quick inspection. Once you create your data, the first thing you want to do is see if your data is correct and see if it was successful. For a lot of people, that means just figuring out how to open your data and figuring out a tool that will let you see your results. There's lots of tools, depending on which field you're looking at, that will actually give you good results. The next step is actually creating a tool that's tailored for you. You might realize that the tools that are out there are just the beginning, and there's really more information that you want to learn from them. That means you actually have to go in there and actually start creating your own tool. Being in a scientific research environment, most times that means creating a tool that would only have a short life. You create a tool, you open it, you know you can interact with your data, you learn what you have to do, maybe you create an image for publication, and then you just move on. In other cases, you actually try to create a much stronger tool, a much more stable solution that you can actually put in as part of a batch process or a way to actually disseminate your data. You might have data that's actually coming out of an instrument that then you allow people to tap through a web interface to actually look into the actual data being captured and actually visualize it and try to analyze it. These three different stages use many of the same common tools, but your level of involvement and finally the type of software engineering you're going to have to do for each of these is going to be quite different. So the next thing is to talk about exactly what goes into this pipeline. What is driving this pipeline? Well, as I said before, it is really about the story and what your goal is. What is it that you're trying to achieve? For that, you have to look at both the goal and the data itself. And it turns out that if you're talking about the data, the thing that actually divides the world of visualization is really the geometric structure of the data. So let me refine on that. We can say that data is either unstructured or abstract data when there's actually no basic physical position or dimensionality to your data. Think of basically as a table of data. Once you have this kind of data, you have to figure out, okay, how am I going to map it to the screen? How am I going to create a visual representation of this, come up with a paradigm, and then interact with it? This area mostly falls out as what we call infovis. The other type of data we would call structured data. This would fall more under the realm of 2D or 3D dimensional data or multidimensional data, but actually has some physicality to it. Think of it as a mesh or an object that you actually know the positions in space. In this case, the mapping is pretty straightforward because you already know it has a physical geometry to it. So you can enhance this by actually adding more visualization paradigms to it, ways of representing your data. And again, once again, interaction is going to allow you even further feedback and further understanding into your data. This area of data visualization is now called SciVis, for scientific visualization. A good resource to find the current work being done both in InfoVis and SciVis are actually the InfoVis and SciVis conferences, which are both IEEE. Now there's also the Computer Graphics Conference, SIGGRAPH, which every now and then does publish strong visualization papers. You can turn to either to the ACM portal or the IEEE Explorer portal to find the latest research and the latest papers. Here is an example of what abstract data would look versus 3D data. In 3D data, for the most part, you have, or structured data, you have basic physical components, either points or triangles, triangle meshes, tetrahedra, finite elements. While abstract data is mostly tables and rows of data. Here's an example of a visualization of a table versus a visualization of something a little more complex, like a mesh of a dendrite. Now what's interesting is that while we do divide these fields into abstract data and structured data, we can actually flip back and forth between this information. You can always find the first three fields of a table and map those to an XY position, or even triangulate this data. And separately, or the same way, conversely, you can actually grab all the information that you have from something that actually has some physicality to it, from a mesh, and just look at the specific data points and specific variables at each point and just treat it as a table. And then you can do all sorts of interesting statistical analysis on it.